This is Geometry 5.6. We're going to talk about kites. A kite is not a parallelogram. A kite's going to have some properties that are similar to some shapes of parallelograms, but they don't hold up all the way through. Here we're talking about a kite has perpendicular diagonals. That's true about a rhombus also, and a square also. But this shape is not a rhombus because it doesn't have all sides the same. It has consecutive sides the same. That's unique. And obviously, it does not have two sets of parallel sides. Look at those sides. If you trace those sides out, they're going to intersect. They're not parallel. A kite has two sets of consecutive sides congruent. Two sets of consecutive sides. Here's one set of consecutive sides the same. And then we have a second set the same. But opposite sides are never the same in a kite. Another property that we have that's true about a kite is we have one set of congruent angles. It's the angles that are between the different side lengths. That makes it complicated. But between the different side lengths, those two angles are going to be the same. Some of you might say, well, it's the top angle and the bottom angle. Well, you might turn the shape over and it's no longer the top angle and the bottom angle. So you can't always just assume it by that. But it is between the two sides that are different, those angles. So when we come over here to this first example, we look between our two sides that are different, and we know that we're going to have congruent angles. So these are both going to be the same value. So we can call them both x, if that helps you. What do we know about the sum of the interior angles of every quadrilateral? 360. So 70 plus 88 plus x and x is always going to add up to, in this case, 360. Because a four-sided shape, the sum of the interior angles is always 360. This is 158 when you collect like terms, and 2x. We're going to subtract 158. That'll leave us 202. What would we do from here to figure out what each individual x value is? We would divide by 2. So x is going to be 101 degrees. This second example is a little bit different. You got to pay attention to the information that they're giving us. There's the two sides that are different. So between the ones that are different, those angles have to be the same. So this is also 113. So how are we going to use this information to write an equation? You go ahead and try to come up with an equation. You can pause the video, write an equation, and see if you can solve it to figure out what angle W is. So we took the measure of angle W, 113 and 113, and the 37, and we added those up to equal 360. We collected our like terms, we subtracted it across, and we found out that the measure of angle W was 97. Now here's a tricky one. We did talk about this yesterday. Pay close attention to this. AE is 3. So that means from the vertex to the intersection of the two diagonals is 3. DE is 4. And that's going to be the same as BE. Because the diagonals, one set gets bisected. Not both diagonals get bisected, but one set does get bisected. And then EC is going to be a different number. It doesn't have to be 3 times 3. It doesn't have to be any crazy pattern compared to those. But it is different than the 3. So, if a kite, then diagonals are perpendicular. So we have the diagonals perpendicular. So that means we actually have 4 sections here. These are 4 right triangles. That is exactly what we're going to do. Pythagorean theorem. So we have a 3 and a 4, and our unknown amount, we'll call this dA. dA is the hypotenuse, 3 is a leg, and 4 is a leg. So we're going to do hypotenuse squared equals leg squared plus leg squared. This is the Pythagorean theorem. You need to be familiar. You can use the Pythagorean theorem if you're working with a right triangle. So we don't know what the hypotenuse is. We can call that AD if you like. Not 80, but AD. The leg is 3, so that's 3 squared. The other leg is 4, so that's 4 squared. So AD is going to be 9 plus 16. So AD is going to equal, AD squared is going to equal 25. This is telling us that the value of AD times itself is 25. How do I figure out what's just AD? You've got to take the square root of both sides. That's the algebra that gets rid of the square. So now you have AD equals the square root of 25, and we all know that that's 5. So this guy is going to be 5, and so would the other side, because that's the same 3-4 triangle. A Pythagorean triple could have gotten you through that quicker if you know your pattern of 3-4. If those are the legs, the hypotenuse has to be 5. 3, 4, 5. Okay, we can do the same thing here for the other right triangle. We have 4 and we have 9. This is D and C. So CD squared is going to equal 4 squared plus 9 squared. This one is not going to come out to be a whole number, correct? So CD squared equals 16 plus 81. CD squared equals 97. So CD is going to be the square root of 97. Well, the square root of 100 is 10, so this is almost 10. But 97 doesn't break down any better than that. Definitely not with any perfect square numbers. So that's the best we have. The square root of 97 and the square root of 97. That's a number bigger than, well, it's smaller than 10. And it's bigger than 80, square root of 81 would be 9. So this is much bigger than just the number 9, but it's smaller than 10. That's an approximate to let you know that the hypotenuse is supposed to be the longest side. All right, these are some that you can try. We'll try to get through a couple of these. If you can pause the video and work yourself through this one, that would be great. You're practicing your Pythagorean theorem. See how that works out. If you have your diagonals, a kite has 2 sets of consecutive sides, so the diagonals are going to be perpendicular. So you're going to have this right triangle. Now, do you remember the pattern we learned yesterday about an isosceles triangle having the 2 legs the same? What's the hypotenuse going to be? Was a pattern we talked about yesterday. Not in great detail, but something that you'll practice even more in the future. Okay, so if you're not sure, this is the hypotenuse, this is the leg, this is the leg. Hypotenuse squared is going to equal 6 squared plus 6 squared. 36 plus 36. The hypotenuse squared is going to equal 72. Now we'll have to take the square root of both sides. And when we take the square root of 72, we can break apart that 72. That's 2 times 36. And 36 has you can square root that. It is a perfect square. So that would be 6 root 2. That was your shortcut. That if you're working with an isosceles triangle, right triangle it has to be, your Pythagorean theorem will give you a hypotenuse of root 2 times the leg. Now the other triangles that are formed in here has 6 on the side and has 12 for the hypotenuse. This is going to be another pattern that you're going to learn in the future. When the short leg and the hypotenuse is double the short leg of a right triangle, then we automatically know what the long leg is. We haven't talked about it yet. We'll talk about that in detail in the future. So we'll have to do hypotenuse squared equals leg squared plus leg squared. And we'll just call that x. So 144 equals 36 plus x squared. When I subtract the 36 over, we get 108. Now, what do I have to do to get just the x? Square root. We have to square root the 108 to get rid of the square That's taking the square root of both sides. Now 108 can be broken apart. We could take our time and try to figure out how the breakdown works, but it is 3 times 36. And 6 times 6 is 36, so that is 6 root 3. So these two are, this side in the middle is 6 root 3. So what we've learned is that if you have a short leg and the hypotenuse is double that, then the long leg is going to be root 3 times the short leg. That is always going to happen in that pattern. We'll study that later on when we solve right triangles. All right, now these are ones that you've already worked with. We know, looking at our triangles here, or our kites, that 125 would be our unknown angle. So solve for y. 13y plus 9y. And our 125 and 125. What are those 4 angles guaranteed to add up to equal? 360. So we collect like terms. So this is 24y and 250. 24y, I'm going to subtract the 250 over, and that's going to give me 110. And then when we calculate that out, let me show you. So we have 110. Well, let's take a step back. We have 360, and we subtracted our 250. Then we're going to divide that by 24. That doesn't come out evenly, does it? Oh, because 13 plus 9 is not 24. 13 plus 9 is 22. Did you just copy me, or did you understand where the numbers came from? So now we can divide 110 by 22, and we get an exact 5. So y equals 5. Okay, then our last example, you know these two angles are going to equal each other. I think that's a minus 30 there. So subtract your 3x, add your 30. So x is 35. This guy down here would be y. And you could go ahead and do all 3 angles add up to 360. This is...
Bye, Mr. Weber. Have a great day. What?